Hey guys. So in the previous sessions, we built a cat health agent, and it worked fine in our workbooks. Um, we went through quite a lot of things, but when things start to really hit production, and real traffic starts to hit your agent and application, you really need to start to implement guardrails and caching. So guardrails kind of, you could describe them as they control what goes in and out of the model, and they kind of make sure that it remains on track with what it's supposed to do. And then caching is more of an optimization and prevents you from having to rerun the same query twice, um, and saves you a bit of money and improves performance, which everyone likes. So, kicking off with guardrails, we've got the system prompt, and that kind of defines, well, gives a primary way of how the model will behave, and that's what's defined in the system prompt. But then guardrails sit outside of that, um, and they don't. They're kind of like a supervisor watching over the guard over the model. So there's three primary places where intervention with guardrails can happen. The first is input. So before the model even sees the message, we can have guardrails there. The second is kind of policy rails, you could describe them as, where we set call limits and tool allow lists depending on the query and so on. And that's more to do with the graph itself and kind of defining the policies within that. And then the last is the output. So after a message is drafted and before the user sees it, we can have guardrails there as well. So in the example that we'll go through shortly in the workbook, the user gets a message. You can see here we've got input rails, deterministic rails, so it's using just regex, which is pretty instant. And if it's an emergency like seizure or poisoning, well, then immediately escalate it. Don't worry about using an LLM to generate a response, because the user shouldn't be looking at their computer because their cat's probably sick. Then on top of that, there's an example where an injection is needed, and then yeah, if it's something that the model shouldn't answer, like how do I inject my cat, well then it shouldn't answer that and it will refuse, and the model's never called. Then here you get personal identifiable information given that gets redacted in this input rail before being passed on to the model. And then there's a scenario where there's no problems and the model can go and answer the question. The idea with all of this that we can see is that kind of the ordering of it, where regex is very cheap to do, and you kind of start off with that. So you go with the cheapest and the most certain option first. So regex costs nothing in dollars and microseconds of time. Whereas if you start to add, say, another model in front to determine, is this question health related? Is this an emergency? Is this something I shouldn't answer? Well, then you've got a model call here, and that's delay. That's takes a bit of time and also costs a bit of money. So let's just keep looking at this for a minute. We can see here that eventually the model model-based guard. So once we've done the regex, we then go onto the model-based guard, and then that determines whether or not it's on or off topic. And then you see an allow with topic redirect, or it actually is on topic with the cat house and then goes into the agent loop that we're so used to seeing. Drafts or reply, then you can have output rails here. If it's something to do with dosaging of medication, well, you probably shouldn't be recommending that, so replace it. It's missing, it should have a vet disclaimer in there, make sure you append it. If there's personal identifiable information in the output, well then redact that, otherwise it's clean, pass it through. It's pretty simple but very important. I think another point to make with the kind of decisions that need to be made, it's better to have not like a true or false kind of narrative that forces you to either block or allow through cases. It's better to have kind of a nuanced scenario where you have like allow, which allows it to pass through, which is normal, and then there's scenarios where, say, it escalates, and the chat, and then there's also, block, a scenario where you can block, or then there can be also a rewrite. So it's kind of like you see here in the PI in output. It's kind of more gray and allows for a better experience. So just looking quickly at the guardrails scenario, it follows pretty much that workflow diagram that I just showed you before, but you can see here we go into deterministic model based, why you should always go for the cheapest first, and it's deterministic, whereas the LLM classifier may or may not misjudge things. Then depending on the decision of it not just being a yes or no, it's better to kind of break things out, as you can see, into these 4 criteria. You can see our regex patterns here, injection patterns, email patterns for PI, phone patterns for simple regex. This is also, these kind of patterns and emergency patterns are very, if you don't catch it, that's why you've got the model there as kind of a secondary catcher. Yeah. Then you've got topical rails, where we use LLMs to judge whether or not it's off topic or on topic, the question. And you can see the topical guard prompt with a dedicated output that's expected, and you provide either it's on topic or it's off topic, true or false, and give it a category and a reason. Having that auditing trail there as a reason as to why this question wasn't answered is very important, and why it got this classification. And then on the output rail, so once the output's actually produced by the LLM, you can have additional rails. So you can see here we've got our vet disclaimer, a fallback message, yeah, so you've got, in LangChain, you've got that middleware that you can add where at the you can add those tags at before model or at after model to hook in the right kind of rails where you want them to be. So yeah, that's interesting and important, but let's jump into caching. Caching isn't new. It's it's a core software engineering concept to improve latency and speed. But when it comes to giving a response for an agent, caching needs to be a little bit more nuanced than just TTL. So in our example here, we've got our incoming query, and then you get a guardrail check of whether or not to escalate it. If yes, well then bypass the cache, never read, never write, and give an answer straight to the user. If there's no need to escalate, well then check, is it an exact match cache string? Yes it is. Then it hits the cache, bada boom, bada bing, you spend 0 tokens, and an immediate answer is given to the user. However, if it's a miss, say there's 1 character difference, then a semantic cache can be used. The cosine similarity of the query can be determined, and if it's above a certain threshold, here we've got the similarity greater than 0.9, which is pretty much saying it's the same question but paraphrased, then it's a hit, and all you had to do was embed the query to get the cosine similarity, and you get an answer straight to the user pretty quick. However, if it's below that threshold, well then it's a miss, and we go into calling our model as we usually do, and here we've got 3 paths. So we've got our live model call, and it places a store in exact plus semantic cache, which we saw back up here. Then there's also, was a tool call needed? Yes. Then we've got a cache on the tool results. That's got a time to live. If it's a hit within the TTL, well then use that response from the tool. If it's not, it's expired. And then there's also the provider prompt cache. So this is more on the provider side. So say we're using a Claude model, well then Anthropic can have a prompt cache and a prefix reuse, and they give you a discounted cached input tokens. So that's something you don't really handle, and the provider handles. So let's jump into our code and have a look at caching. Let me scroll to the top. So, like it says here, every LLM call costs money and time, and caching is supposed to improve that. So, you've got response caches, which are kind of that exact match and semantic matching to the query and then giving the response. And then you've got actual artifact caches like embeddings and tool results that you can also cache. And so we go into a few of those here. So we establish a baseline of asking the question twice with no caching. So you can see the first ask was 3.18 seconds and the second was 1.63 seconds. And once you start to have a bigger user base, the caching can become a real cost and time saver. Yeah. So here, looking at the exact match response caching to see whether or not the user query matches one that's already in the cache. But you can see an exact match caching. The limitations kind of to you need that question to be identical, so an exact match. So it's good for kind of programmatic. You can see batch jobs, agents re-asking a fixed sub question, and so on. But you know, humans, we tend to say the same thing but rephrase it. You know, you might say it in American English or Australian English, if you know what I mean. So a semantic cache here stores the query, embedding, and answer. Yeah, as it kind of it's kind of self-explanatory, but you get the query in, and then you embed that, and you see if you have matches above a certain threshold, and if you do, well then, bada boom, bada bing, return that response. So you can see that here. My cat just ate chocolate, what should I do? And my cat just ate chicken, what should I do? The the cosine similarity between these two is 0.743. And it's very important, like in this scenario, you can see it's actually quite high stakes in that the cat can eat chicken but not chocolate. And this is where having rails becomes really important for your agent, because a question that has this kind of phrasing is should be escalated, and you can see that's described there. Then it comes into caching embeddings and tool results. So you can also cache your tool results depending on your tool, they might look different. So usually there's a time to live for the cache, and if it's below that and the input was the same, well then the tool call output should be the same, and you can go ahead and use that without having to call the tool. And then lastly, provider side prompt caching. Like it says, it's not yours, it's the provider, and it's controlled by them and how they've set things up. You actually see this in a lot of your billing. So if you look at your token usage, you'll have cache input, cache output, and then also input and output. So yeah, something interesting to go and check out. But all in all, I hope there was something interesting, and I hope, yeah, you add guardrails and caching to your agents. Thanks for listening.